Hi, everyone. I spend my work time helping ventures or startups to get their products to markets faster. That's my primary interest since a couple of years now. And basically, it's all about acceleration and trying ideas in a very rapid fashion, but also seeing the architectural abstractions and boundaries emerge as a natural process of trying many different things faster. And I found that there are different forces at play when you're building something completely new product within existing domain, but maybe you're going through the uncharted territory in terms of like a software to a larger extent. And the decision-making process, especially around our architecture, is slightly different there. And I always struggle to communicate that difference, to discuss that difference with the teams when we just get started. And then I thought, hold on a second, architecture decision records, we can use them as a drive to tell the story and to explain and illustrate the insights that were always innate to me, or were always kind of on the back of my mind in terms of the difference and how do you approach startup delivery, startup architecture. Architecture decision records, or ADRs for short, if you don't know, it's a super simple markdown documents that you store inside your code-based repository. And they basically describe the decisions that you made that had an architectural impact on the delivery of the software, the context for those decisions, and the consequences, both positive and negative of those decisions, upfront, right? So that kind of forces you to consider the decisions that you're making ahead of the time. And obviously, just talking about architecture decisions isn't that much useful. What we're going to do through the rest of this talk is I'm going to actually extract the architecture decision log from one of the ventures that I'm helping that is around 3.5 months into the 6 months delivery from the very beginning. So I'll take all the architecture decisions from that and present it to you, and we'll talk through them. And you can split this talk basically in two halves. The first half is me basically talking through those architecture decisions. Might be a bit boring, but I think it's important for the second half of the talk to make sense, where I would try to use those to draw an insight and to kind of to do a full loop to the beginning of this of this talk, right, where I'm describing the insights and the difference that I see to how the teams that I work with approach architecture to the teams that approach architecture in the wild. For obvious reasons, I will show the real architecture decisions, but I will blank out all the brands, names, characters, and there's certain language that I had to take out for IP reasons. So first, the problem space of the venture that I'm talking about. The problem space is the medical morbidity. Medical morbidity is a very interesting challenge in the medical space. Basically, people as they get old need help in terms of medication to help their body kind of sustain the age. And it's not unnatural when you get to a very old age of like 70, 80 years old, for you to take 8, 10 different medications all at the same time to support different parts of your body and help you to maintain and sustain your health. And as you can imagine, as with anything, those 8, 10 different medications have contraindications. They might have conflicts between themselves. In addition to that, your patient condition or your condition as a patient might also have some contraindication to certain medication. So the best case scenario is obviously to assign a clinician or a specialist in medication to every single elderly patient and just scan through their medical history, scan through all the medication that they take, and generate a very personalized advice to make sure that the medication they use is very much matching their case. Which, as you can imagine, isn't possible at a scale. You can't do that at scale. So what happens is it's at the government level or the industry level, there's this trade-off happening all the time where we're trying to balance out the investment in time into the patients, right? And obviously, some people are living less years than they could have been. Hence the medical morbidity. So the general timeline for this product that we're talking about, the venture that is addressing this problem space, The venture team of the founder team got an initial limited investment into research and development, basically build a retrospective study, build a very simplistic prototype to prove that they can generate recommendations and scale within a very small HMO design partner. That was in the May of 2018. The research and development took a bit longer than it usually does with startups and the new products. But by September was the point where I was brought in to help the CTO and the rest of the technical team to see this product in a form of pilot or MVP to the initial launch in April 2020. And by October 2019 is where the rest of the team joined the product delivery, where we kind of went all hands on deck and tried to deliver this project to conclusion or to the hands of our first customers or users, doctors within the HMO. So the rest of this talk is basically this. So this is an extract of architecture decisions of the months from September through through the beginning of February, basically. All of the ADRs are true and real, just extract from the repo. As you can see, there is a couple of them that are blanked out at the very end. They're very much related to the inner workings and what people consider as the core domain starting to emerge of this particular product. So, the story so far. What I'm going to do for the rest of this, half an hour or 20 minutes, is I'm going to talk you through every single decision that we made here. Right? We'll go through them as a timeline. And I would provide you some context. There will be ADR flashing on the screen. Don't worry about reading it too much. I will provide you all the context you need to have. It might be a bit boring, but you have to have this context for the second part of this presentation to make sense. And hopefully there is some useful nuggets in that talking through the individual decisions. All right, so let's start before I joined the project, or at the very beginning of research and development, or the prototype build, which started in the May of 2018. The first decision, architectural decision that was made on this delivery was the team decided to use Node.js and Postgres as their technologies of choice. Primarily due to the reasons that the team was very familiar and comfortable with those techs, and also the team felt that they would benefit greatly throughout the delivery of the prototype from a really rich ecosystem of packages of a node. And it actually served them really well. The retrospective study went really good. It showed a promise in application of those automatically generated recommendations to the field. However, when I joined CTO and started having discussions, technical discussions, and the business discussion with the rest of the team, it became obvious to me that kind of Node.js outlived its capacity to support this particular problem space. There were certain areas where the technology and the platform just didn't match the problem space that we were operating in. In particular, there were challenges, serious challenges around the data mapping layer and the parallel execution or multi-threading, which both are possible to do, but very hard to achieve within the Node.js environment. In particular, we went through the code base and we estimated that around 70% of the code base at this point in time were dealing with accidental complexity, as in only 30% of the code base at the end of the prototype were actually focusing on solving the business case of the medical morbidity or medication analysis. So at that point, I took a liberty of basically running a spike, a one-week spike of researching other alternative technologies that we can use on the product. I narrowed it down to a small subset of the languages and the platforms. And in a week, I built 2 prototypes, or rebuilt 2 prototypes of a small horizontal slice through the entirety of the analysis engine. So the one that won by a large margin was the one built in Erlang, in Elixir. And I presented it back to the technical team and sold it as, here's the list of the issues that you flagged. Here's how we can address them by utilizing this new platform. And here's potential benefits that we can reap down the road. By the way, this shift is not as big as it might sound, because just in a week, look what I've done. If you join me, we can actually rebuild majority of your platform in a month's time. And that leaves us 5 months of not fighting with the platform that doesn't match the problem space, but actually succeeding with it. The next decision that we made, basically in the same week of the beginning, is we decided to use an off-the-shelf CRUD/MVC framework. So when you usually start building from scratch, which is what we did there, we leveraged all the knowledge and learning that we did in the prototype, but we started from scratch building the product. You have a choice. In a more mature domain, my natural choice, I would gravitate towards starting from defining a core domain and the core use cases within it, and we'll leave all the auxiliary functionality like UI, databases on the side. However, here, although we did know what the analysis engine looks like, we didn't know what the user interface should look like, how it should evolve, what are the use cases, what's the interaction between doctors and the system is. And in this environment of really high uncertainty, it was really, really hard to commit to what is the core domain, what is the core part of the application, what's the split is. So what we decided to do is, controversially, is we said, look, we're going to just use the framework, we're going to use it off the shelf, and we're going to just follow the rules that the framework dictates. So analogy would be, if we decide to use Ruby, and we decided to just use Rails and scaffold the application around that without breaking any of the conventions of the framework. That was a temporary decision, but we felt that this is a good decision that allows us to temporarily to learn enough about the domain to progress forward. We also decided, well, as you can imagine, integration was a big HMO. The entire product is built around the idea of reading almost in real time patient data, which means that we need to integrate with that patient data. HMOs, as any other big organization, requires time for you to get access into them. Although we were given a sample data set of basically 1 year of 100 patient medical history, obfuscated properly in the prototype, we didn't yet been granted direct access to the HMO data set. So we could have approached it in multiple ways. We could have just decided to stop the project and wait for the access to be given. We also could have just used the specification of the HMO data set and build basically the abstractions on top of that, and integrate as per spec. What we decided to do instead is just use that sample data set that was given to us, although obfuscated, and use that as a fundamental building scaffold for applications. So we will build and train all our analysis engines based on that data set, with all the risks and drawbacks coming with it. Obviously, if the data set diverges between the sample data set that we were given during the prototype and the real thing, we might be a couple months away from the launch. So that's the risk that we felt we could take, but that's the risk that we had to manage very strictly on the business side. So at this point, what you have is you have 1 year of history of 100 patients, which is approximately from that sample data set, around 40,000 medical events. And you basically run those medical events through the analysis engine that generates you a list of recommendations for change in treatment. And obviously, there will be errors. Obviously, there will be issues. And obviously, you have to present that information in a certain way, in some way, to potential users, customers, and even internally within the team so that you can establish a feedback loop around that functionality. The common approach that I see people take is you have to be able to debug the results, so the results need to be stored somewhere, like in the database. So you start bringing up the database structure. Elixir actually has a really good relational mapper library that integrates very closely into the Postgres, so we could have brought that in, established our first set of migrations, defined a data structure, and stored the results in the database. However, we felt uncomfortable about our level of understanding of what UI we will end up with in a month's time, but we also felt that there is a lot to learn about the structure of the results and the complexity of those results before we can commit to the database. In simpler terms, it felt like if we commit to the database and commit to maintaining migrations in those first months or two, we would pay incredible cost during the delivery of maintaining those migrations without getting that much value out of having that very fixed database structure. So what we decided is to use one of the kind of big advantages of Elixir and Erlang ecosystem, which is you can actually sustainably store data in memory, in RAM. You can do the same with Java.NET projects, like run the long-running process and just store your results in memory. The difference with Elixir is that Elixir approaches its runtime as an infrastructure. So you have actually out-of-the-box tooling for introspection and analysis of the process's state that we could just leverage without building any additional tooling or functionality around that. So we decided to basically keep everything running in memory and expose the UI from that state of analysis in memory. And whenever we needed to upgrade our code base or relaunch the analysis, we can just rerun the entire analysis. Takes 20 seconds, and we see the entire result set there. The most controversial decision here is that we decided to do all of the import and analysis at this stage, and remember that's just the first week, right? In one single module, file, or if it was object-oriented language, class. So basically, we knew that we have three responsibilities there. We know that we have to import data from HMO-defined data structure. We knew that we need to run analysis, and we knew that we need to present it in some form to the end user. Instead of trying to split that into three different responsibilities from the get-go, we said, again, we don't have enough understanding of where the boundaries are properly laid down. We knew that we probably will emerge with those three components, but where exactly to draw the boundary between the three wasn't entirely clear. And it became clear that we didn't know where to draw the boundaries as we started kind of drawing on the whiteboard and discussing what goes into the import and what doesn't go into the import. So instead of trying to force the issue and spending a lot of time in argumentation and back and forth and moving things between the modules, we just decided to put everything into a single file for the time being. We then conducted thorough interviews with our customers, which in this particular case were doctors, and we facilitated sessions where we would observe how they actually interact with the problem space. And what we found out expectedly is that there is already medical process in place that they were following. It's just they couldn't apply it or scale it to the entire population. And the process is very much predefined, where the way they would analyze the patient is a two-tier research or analysis into the patient. The first tier is they would look through the medical history of the patient, through the medication history of the patient, and they will extract what they call features, basically the patient status. As we all know, event sourcing, you can think of it as they would project particular medical events into a singular representation of a state, and they call it feature. An example of that would be systolic blood pressure, right? You look at the blood test results of the recent months, you look at the last one, you extract systolic blood pressure, and that becomes systolic blood pressure feature. Based on the subset of those features, they will then make a decision or recommendation to that patient. So if the systolic blood pressure is too high, they would recommend to a patient to treat the blood pressure. That's as simple as it gets. Obviously, it gets more complicated when the medication and dosages get involved. So what we decided to do in the system is, in that same module, is we're going to split the entire analysis into two analysis engines. We will have a feature engine, which is you define a projection of a medical history into a singular state or value, and then we would define a recommendation sub-engine or analysis engine, where you would use those feature values to generate or drop the recommendation. And that was a crucial decision because that allowed us to have a conversation with doctors using the language that the doctors would utilize. At that point, we started seeing that there is a weird divergence in the language that we use in the conversations with both domain experts and customers that we were interviewing at this stage. Because the language that they were using was fairly different to the language that the team was comfortable with at this point in time, that they used throughout the prototyping build. And the difference was that the language that the team ended up using at the end of the prototype was more akin to the data warehousing language. So they used the terms like ingestion, staging, and those terms, as you can imagine, were completely alien to a doctor that you're discussing. Doctor would talk about EMR records, they would talk about analysis, they would talk about medical events. So there was a fork in the road here, because even at this stage, if you can look at the code that we were writing, at the logic that we were implementing, you can actually fairly easily qualify it as that's a data warehousing process. We get a huge amount of medical data, pipe it through some sort of a transformation function, and out comes the list of recommendations to a patient. So that is data processing at scale and data warehousing. However, that's not the product that customers were buying from us or the product that we were planning to sell to doctors and HMOs. The product we were selling is a pharmacology analysis tool. So we decided to align the language of our tool set with the language of our customers, which is pharmacology. So we started renaming things from import to EMR records, from rule engine, which is too generic, to a patient analysis. At this stage, that single file, and that's at the end of the second week, at this stage, that single file where we were doing all the import processing analysis became too unmanageable. It was really hard to track the changes between the two subsets of interactions that developers had with the code base. So in particular, we started spotting that there's a lot of merge conflicts happening there. Well, not a lot, but we started seeing some merge conflicts emerging. And we also started seeing that there are certain forces that are applied to a certain set of functions that are to do with analysis, while there is a certain other forces that are applied to the set of functions on a different change cadence, which were import functions where we would map the data from the EMR. And most of you would not be surprised, and we weren't surprised. We knew from the beginning that we'll probably have to separate those two modules. What was surprising to us is how easy it was at this stage to actually separate those two sets of functions into two modules. Because not only we knew where to draw the boundary, we knew which functions to move into that boundary, right? The import, what belongs to the import and what belongs to analysis became a very simple question, because all you need to do is just look at the recent change cadence of a function over the last couple of days, and you identify that this is changing together with an import, this is changing together with analysis. So we basically generated a pain for ourselves, but then used that pain to gain an insight into how to split the functionality. And we also had a discussion with the rest of the team, in particular domain experts, where the concern was raised that from the point at which we validate and confirm the rules, and we start encoding them into the code base, the oversight and visibility of those rules is completely lost for an experts in the team, obviously, because we transform them into code. We can teach people code to a certain extent, but there is a limit to which you can expect your domain experts or your doctors to spend time in understanding your Elixir code. So what we decided to do is just leverage capabilities of Elixir to create a domain-specific language. We leveraged the macro capability, and we created a very succinct, very small subset of a language rule for both the feature rules and the recommendations. And we grouped them all outside of the SRC folder, outside the lib folder, in the root of the project so that the doctors can easily find their way into it. And our hope there was that despite us paying double cost now for managing the rule engine or patient analysis, because now we need to maintain not only the patient analysis, we also need to maintain the DSL layer, and we also need to onboard new people or new team members, developers, into both of those when they get into the project. The value that it brings is that the doctors will spot issues in our rules and will start contributing into those rules in the long run. And because we didn't operate on the real data, but we already started seeing some inconsistencies in the sample data, there was another fork in the road where we could have decided to start kind of locking down the structure of the import process and the conditions that we put on it, right? So we could say, the dates should come in this format, and if they don't come in this format, we don't accept that medical event. So basically introduce the sanitization and validation of the input data. And for two reasons, we decided not to do that. The reason number one is, again, we weren't operating on the real data, so we didn't have confidence that the rules that we will implement will be actually consistent between the sample data and the real data. And second is, we also felt that we didn't have yet enough grasp or understanding on individual fields to apply any sort of valuable sanitization rules. In a simpler terms is, we felt that if we are to make those decisions right now, all we will do is start changing them all the time while we're learning about the domain. And if we are locking our ability to learn, that just hinders our progress. So we didn't say we don't want to do import handling. We just said that we probably need to learn a bit more about the import data and the state of that data before we jump into locking it down. So at this stage, we moved into October, and that's where the rest of the team started joining us. So at that point, we just were a technical team, basically re-implementing or rebuilding the core of the platform in Elixir. We kind of finished with that by the beginning of October. We had most of the system implemented. Beginning of October, or middle of October, sorry, obviously we had to show something to the rest of the non-technical team. And we, again, had a fork in the road. We could have invested into building a beautiful UI, or we could have just output it on the web, in a web page using the CRUD functionality of the Phoenix, the state that we already had. And that's the route that we decided to take. So we would just output the in-memory state of our analysis process on the page. Didn't look good. You can't show it to the customer, but you can show it to a doctor or the expert within the team, and they can already generate a useful feedback to you and say, this rule doesn't make sense. That recommendation in this context doesn't make sense. And this is where we're getting into already on the second month into the first reversal of one of the decisions that were made. So as you remember, we made a decision to use the pharmacology language. And as soon as we kind of exposed the UI to our inner team, and they started seeing some of the terms being used, we noticed that the business people in particular started having a lot of the confusion around the terminology. There was a lot of arguments of how to name things. And all of that were due to the fact that a lot of the conversations about the business and discussions around the architectural boundaries, and also a lot of the documentation that was produced during the prototyping was also produced in the language of data warehousing. So a big chunk of the team at this point, outside of the technical team, were speaking about the product, but using the different language to the technical team. The technical team tried to steer very heavily towards the pharmacology, while the rest of the team was speaking language of data warehousing. In addition to that, the technical team was still learning the domain of pharmacology and the terminology that comes to it, so sometimes the naming didn't come easily to us. So what we decided to do here is a bit of a half measure to step back halfway. So 2 steps forward, 1 step back, where we decided to scale back some of our naming into the data warehousing capabilities, right? Again, in the long run, we're building a pharmacology tool for our end users, but to simplify and enrich the discussions we had within the team, as the team at this point were key stakeholders, we decided to bring some of the terminology that they were used to, and also relax some of the issues and challenges that we had about the naming to allow ourselves progress a bit forward. Again, we bought ourselves time to learn more about the pharmacology without forcing that issue straight away. A bit late, but by the end of October, we decided that just showing application from the developer laptop was not good enough. So we basically pushed the entire application into the Heroku as a demo version. The end product, the production environment of the application, will have to be deployed into the on-premise of the HMO. But we felt that there was a lot of the good benefits that would come from just having a demo version with a sample obfuscated data deployed to the cloud continuously, so that everyone on the team, and even our potential customers when we're conducting interviews, can actually observe the real application in its absolute latest state. And then they can see the changes that we enact on this application, not in real time, but on a very, very fast cadence. Obviously, deployment to on-prem, which will be production deployment, and deployment to cloud are fairly different. So we try to avoid a complexity of basically managing 2 completely separate deployment processes. What helped us here is that Heroku, since recently, has Heroku Container Registry, which allows you, in the same way you would deploy a pod, to deploy a Docker image of your application into the Heroku, and Heroku will treat that Docker container as a pod. So they will basically properly scale it and run it, which means that all the optimizations that we apply to those container images of the application, of the Elixir application running inside, are completely transferable to the production release that we're going to do within the HMO. Obviously, pipeline will have to be different, but at the very least, the optimizations we do to the run-in application within the container will be maintained. And only then, so we already, we started with a single module, and then we split the import out of the analysis, so we had two subcomponents. But we still had a lot of the UI-related stuff in our analysis results. But we already started getting some of the feedback from customers that if you are to show me this product being developed, for me, just seeing internal state is not good enough, and I actually need to see additional information about the patients that isn't that relevant to the analysis itself, but is relevant for me as a human being to understand what patient I'm dealing with. So the examples would be that as a doctor, you need to know the patient name and the patient date of birth. Both data fields aren't that much used in any of the recommendation or the feature rules, but are, as you can imagine, are crucial for the doctor to make a decision about that patient or validate that the recommendations that the system generates are correct. So we had a conundrum at this point, which is we were exposing the internal analysis state on the page. We could have just added those fields into our analysis results. So say our rule engine now produces name and date of birth as part of the analysis, and that's fine. Or we could have separated that completely. So we could have separated our UI and from our analysis and say they both maintain different state, and there's a very slim line of communication happening between the two. Looking for the feedback that we got from the customers, looking at the potential change cadence and the changeability of the UI that we'll have to implement, how often we will have to change the rules, and how often we'll have to change the UI, we quickly arrived at the decision that the best course of action will be to invest in separation of the UI state from the analysis state and actually maintain those two separately. It's a bigger investment, so now you have two states to maintain, and you also need to introduce the communication layer between the two, which we just utilized, Elixir's PubSub. But we felt that the benefits of us being able to evolve UI and analysis at a completely different cadence were worth it. And that is one of the things that allowed us to start working, to start doubling down on building the UI. A second benefit that we just got as a side effect of moving into Erlang, and Elixir in particular as an ecosystem, is that it allowed us to build a very rich interactive UIs for our doctors without writing any lines of JavaScript. So basically write very interactive dynamic UIs in the code that we were writing our analysis, which is Elixir. Elixir's Phoenix Live View is an extension on top of the Phoenix framework that allows you to basically utilize the React-like development patterns where the state is managed on the server instead of the front end, and the changes are communicated through the very slim WebSocket connection through the diffs to the browser. Obviously, it has limitations. One of the limitations is that it's very hard to have an offline support with that. The second limitation is that latency can potentially kill you. Both of those limitations weren't a huge factor for us as we were planning to deploy the pilot or MVC on-prem. And we felt that the advantages of us being to be able to stick with a single language, not expand the skill set of the team, and not spread our focus were too great to disregard. So we decided to build the UI in Live View. We also decided to, in a similar vein, to avoid bringing not only JavaScript, but avoid bringing the context of the CSS or managing style sheets into the application. So we decided to use utility first framework, in particular Tailwind CSS, which allowed us to basically describe the entire UI of the application without at all worrying about writing any CSS. The drawback is obviously our templates are now full of fairly CSS class names. The benefit is that we can change the UI almost completely or parts of it without impacting other parts of it. And we can do that by just changing the template itself. Later on, that proved incredibly valuable for our delivery. And this gets us to the beginning of January, and only now we're talking about persistence, which is weird because we already had UI built. we already had a fairly sophisticated presentation layer that we started running by real customers. They started interacting with the system. They started generating feedback about this works, this doesn't work, that element should go there, this recommendation doesn't make sense. Although, behind the scenes, the entire analysis was done in memory and run in memory, even when we deployed to Heroku. But the challenge happened where, as we started implementing interactions from the doctors into the system where they can interact with individual recommendations, accept them, drop them, obviously we can't rely anymore on rerunning the entire analysis to restore the state of the UI and application, right? The information will be lost. That's the reason why we said, okay, now is the time for us to look at bringing in persistence. And we looked at different patterns. We looked at bringing the event sourcing framework of Elixir into the mix. But what we eventually settled on is use an event store, not the event store, but Elixir's Postgres library that provides you a batching capabilities and ability to store and stream events into the Postgres. And utilize that to store events in batches on the queue from the patient analysis. So at that point in time, our entire system is every single patient represented with a patient analysis process. We feed that patient analysis medical events one by one from the EMR, obviously transformed and pre-mapped by the import layer. And then that patient analysis on the ongoing basis, in response to those medical events, will produce analysis events, like a feature changed or recommendation raised. And those would be batched out or queued up and stored 100, 200 at a time, or with a delay into the Postgres. The delay was important for us because that's what allowed us to go from processing 80 medical events at a time to 2,000 medical events at a time, or per second, sorry, which was super important for us to still be able to rerun that entire analysis and check validity of all the rules on the ongoing basis. But only now in January, we're thinking about this, and we already know that there are challenges around this persistence. So that queuing mechanism, we needed to make the patient analysis or the gen server process behind it too smart to be aware of those queuing mechanisms. The interesting aspect of that was that even though we were storing the events that were response to both the analysis itself and also interactions of the doctor with the system, we still were storing the UI state in memory, and we were actually planning to store the UI too in the Postgres in form of a snapshot. But after looking that it just takes us around 10 to 12 seconds to restore the entire UI, by rereading all the events from the beginning of time for the sample data, we felt that that's a decision that we again can postpone till the later date where we can integrate with the real data. So basically we have still deployed application to the demo version where whenever it gets restarted automatically by Heroku overnight, it takes 10 to 12 seconds to load all of that memory and rebuild the UI from all the events that happened to it. But after it reloads, it's instant because it's all in memory and it keeps running in memory. So we felt that it's a good trade-off. And again, while we're still figuring out what UI should look like, it was a good trade-off for us to keep that in memory. Again, we'll probably end up storing it into the database in a month's time. But at this point in time, the flexibility and ability to not worry about the database that early allowed us to go faster. We skipped through a couple of business-related decisions, and then we go to the interesting one, which is split rule definitions and presentations. And particular interesting aspect of this ADR is that we dropped the DSL. So you remember we introduced the DSL, and we recognized that there will be additional cost that the team will have to maintain, but we decided to take that cost because we thought that the benefit of our experts looking at the rules after they were implemented would outweigh the costs. So what we found out is that the experts would look at the rules, but not the part of the rules that we thought they would. So the rules started evolving now where they would include not just the conditions themselves for raising a recommendation or the logic of extracting value from a medical event, but they would include some presentational information, like what message to show to a doctor when this particular feature changes, or what message to show when this recommendation is raised or dropped. So that kind of information crept into our rules, and that's the information that our experts, the main experts and doctors, were looking at. Not the rules, not the actual conditions, the labels and presentational logic almost. So what we did is we did two-step architectural adjustment where first we split all the presentation-related logic into the templates. So they moved into HTML templates where we would store, based on this recommendation or feature ID, present this information in this condition. 100% HTML plus Tailwind. We can live view it. We can show dynamic graphs based on that information. But that allowed us to keep the rules super simple and focused just on the conditions of when to raise or not raise this particular recommendation. We then also recognized that, OK, now we have a place where we store all the conditions that nobody looks at except the development team. So we deleted the DSL, reduced the complexity of our rules. Yes, nobody except developers can look at the rules now, but that's something that we can solve later on by introducing a proper GUI for rule management. And we decided that that's another decision that we can postpone till later, till it becomes a problem. And the last decision that was made actually this week was that we recognized that that entire batching and queuing of events, post-processing or like queuing of analysis events, is a very stupid idea. Actually generates a lot of additional complexity around error management, because what happens if you have an error in the middle of processing queue? What we can do instead is just batch in the medical events that come into our aggregate before, which in retrospect is extremely obvious idea. Don't know why it didn't come to us, but it didn't come to us. It did come to us now, though, and it's not a big loss, because we still can readjust and refactor the system. And actually, this readjustment and refactor has a potential of allowing us to bring in commanded or like the event sourcing framework from Elixir, further reducing the maintenance cost for us, because we can drop our own custom gen servers and the processes implementation and just rely on the framework to do that for us. So that's a not so short journey. Now to the interesting part. What are the insights from this entire journey? And again, it's not finished. It's not at the end. There's a couple of decisions that have to be made that are super important. But this is where we are so far. So those insights are, you can also call them retrospective coherence. So this is me just looking back at them, reading through them, and then saying, oh, this is why we made this decision, because later down we will make this other decision that kind of validates this. That's totally not what happened. We had some good calls and feeling of where we should land with this product and where we would land with those particular architecture decisions. But the planning ahead wasn't as inherent and as smart as it might look. However, that said, it's still valuable to look back at the decisions that were made and drive some of the conclusion and insights from that. So the first interesting aspect, just by looking at that history that you can arrive at, is this switch of the platform, where we switch from Node.js to Elixir. And the reason why we did that is because we recognized that the platform didn't support us anymore. It stopped supporting the team. And instead, it started fighting with whatever effort team tried to apply when it was changing it. So what we decided to do is just change the platform and find a platform that is actually aligned with the problem space and the team at this stage. The interesting aspect of this is that I'm working with many ventures or startups, and I don't see this happening as often as I would expect it to, right? It's more than logical when you work on the prototype, your first idea of what the technology and the platform is not that correct, right? Because you're operating in the limited understanding and knowledge. So it's very reasonable to expect that the technology you chose at the beginning should change or be adjusted at the very least after you build the prototype. What I see in the field happening actually is that you rarely shift between the technologies. So even if your technology doesn't work for you, when you transition from finishing the prototype to start building it to market, you stick with that tech because it's the devil that you know, I guess. But we didn't do that, and there were a lot of benefits that came directly out of us not doing that, out of us doing radical change of the platform. And there was a lot of teaching and learning involved for the team. No one on the team except me knew the Elixir in Erlang. But what we found out is that it was way easier to teach that team Elixir and Erlang than to teach that team how to write a Node.js code that would match this problem space. Again, this is not another node. This is just to say that for this particular problem, node didn't work and Elixir worked better. There will be other problem spaces where the entire mathematics will be completely opposite. The most interesting thing for me is that those 4 decisions at the very beginning, in particularly, do all the things in a single pipeline, in a single module. If you look at them in separation, they look extremely naive, right? Those are the kind of decisions that any graduate will make, or any person that just programmed for a year will make, right? And those are exactly the decisions that a team of fairly experienced engineers made at the beginning of this project. Now, did we make those decisions because we thought they were the best at the time and that we will stick with them? No, we made those decisions to allow ourselves time and allow the code base time to come up with reasons for a better solution. We used those naive solutions not because we thought they were best, but because we knew we didn't have yet an idea of what the best solution is. And we bought ourselves time to find that best solution. And another aspect of that is that, it didn't take us that much time to find that we need to separate import from analysis, duh. But it took us almost 2 months to get to the point where we can actually separate the UI and invest heavily into separating the UI. And what I find a lot is that talking about the boundaries and like how to separate the context and what is what component is the easiest conversation to start with the team. It's also the hardest conversation to close with the teams at the very beginning of the project, right? It's super easy to just wrap up the whiteboard and start discussing when you don't have that much knowledge about the boundaries of this exact problem space, to start talking where the boundaries are. I find it incredibly useful to just give it a bit over time, and a bit is a keyword here. I'm not talking about spending half a year without the architectural boundaries. I'm just saying wait for the real forces to emerge and show you where the problems lie, where the boundaries should be drawn, where the change cadence is really different based on the real change, not on your anticipation of it. Another way to look at many of those changes is that we made a lot of architecture decisions that had absolutely zero reason to exist within this code base other than keeping the options open. So the example would be, persistence or the UI. So we created a static representation of the analysis state without introducing any useful information. Was that because we were lazy? Partially. But most importantly, what we did try to do is we tried to gain additional insight and information and the feedback from our customers, from our team, before we start making any decisions about the UI. We felt that if we were on the spot, try to create a UI, we would be able to come up with some sort of a list and a patient view, but that will be investment of time that A, will have to be reverted in a week, and B, the time that we will not be spending learning about the real needs of the customers. So what we did instead is we deliberately went for the options that didn't commit it to any particular way, right? We could have went with a Postgres persistence from the get-go, but that means that migrating to any other persistence mechanism, if we find a better one, would have been that much harder. Because everything is in memory, in RAM, we kept being on the step 1 of the journey, keeping all the options on the table. So yeah, delayed investments in persistence and UI are in particular patterns that I see across many of the new products that are being built. UI is something that you surprisingly can delay for a couple of weeks of the new product. And we have this, as engineers, we have this expectation that the real users or our experts cannot see anything that is not good looking UI. They cannot generate any feedback until it looks okay. And it's not true. Actually, like if you have a doctor that is a stakeholder that is deeply invested in the success of this product because they see the change that it can enact in the world, they don't care if you show them a UI or a plain text file with the recommendations generated and the basic patient information. And he doesn't care that that text file came out of the CLI console command that you generated from your rule engine. So that's how I see many teams are actually getting a lot of the benefits from establishing a very early feedback loop without too much of investment into the user interface. And the persistence is an even better example. As you saw in this particular product, the reason why we introduced persistence is because we needed to introduce interactions with the system that were not coming from the analysis itself, right? In many instances, I see the persistence being brought in too early into the product, and the team could benefit from delaying that until you see the problem that the persistence solves. Different platforms and languages will have different limitations and constraints. In some platforms, you wouldn't be able to avoid persistence for too long, if at all. But when you have a platform that allows you to keep the state in memory and present it and debug it in a very easy way, why wouldn't you do it? Perhaps a lot of you throughout this had a lot of thoughts like, this team seems incompetent. A lot of the decisions that made seem to contradict each other, right? So it's like, oh, we made a decision to go with pharmacology language, then we reverted it. We decided to do the DSL, then we decided to revert it. We decided to batch the analysis events post the analysis, and then we decided to batch the medical events. And you can say that this is an indication of something being wrong. That's not the way I look at it, though. The way I look at it is that we're building a new product. There is a lot of unknowns and uncertainty about it. So the integral part of the delivery of that new product, the only way you can build something that is new and bring it to the market is if learning is an integral part of your delivery. And you cannot achieve any kind of learning if the mistakes are forbidden or if you don't do mistakes, right? So the way I look at this is, yes, there are mistakes, but they are recovered. And that is great, because that shows to me that this team learns. We learn certain aspects. Obviously, you can reach out to the wider market and leverage the knowledge of the industry and not repeat the mistakes that everyone on the market made. But in certain instances, mistakes that the team makes itself is the greatest learning that they can have, rather than you just telling them the right solution. And kind of the side aspect of that is that I see we often talk about technology and the business as being like the fundamental parts. Technology needs to support the business in delivering the value, and the business needs to find like a strategic adjustments to allow its technology to move in the right direction. So like there's symbiosis between the two. What I don't see happening a lot is us bringing the team into the conversation. And the example of bringing a team into the conversation is me saying that, you look at this and you would just say, geez, you could have just used event sourcing from the day one, right? And I could have, with a different team. But that particular team didn't know event sourcing, right? They didn't know how to do the evented architecture. They knew how to do Node.js and data mapping at this point in time. Now, I could have invested into a different team that might have been better at event sourcing but didn't have any clue about this business domain. Or I could have invested a couple of months into teaching that team how to do event sourcing. What we did instead is we started bringing concepts of event sourcing into this team. And I wouldn't be surprised if in 2 months' time we have a more event source system than I thought we would end up with at the beginning of this project. Another interesting aspect is that, why did we drop that DSL? Well, because we listened not only to the words that our stakeholder told us, we trusted their words, we went with them, we're happy with that decision that we went with their words. But we also validated that their words manifested into the actions or the changes, or didn't in this particular case. And that's because we also treated our team as stakeholders. It's too easy to say pharmacology is the language of our end users are stakeholders. Those are the only people we care about. But at this particular stage, when we're just finding grounds with the customers, when we're just establishing the communication with them, and majority of the development happens and the conversations happen within the team are not only the stakeholders, in many cases they are the most important stakeholders you could have. And the conversations you maintain with them and the learning that they go through is as important, if not more important, than the learning that the rest of the team goes through. Those 3 spots that I missed one of the most critical insights and the learnings that the business had. Like they found particular aspects of the analysis engine that they consider a major differentiator for this product, right? To the point that they asked me to blank them out. And it's interesting that they only emerged after like that many decisions into it. And the only way I can describe it is, the reason why this happened is because people don't tend to go in details, even in their domain expertise areas, until you get all the due diligence and the simple things out of the way, right? Although I said earlier that your doctor can generate you feedback without the UI, it's very hard to get a very deep feedback when you show them just a plain text file and you say, just trust me, there will be UI around it. So in many instances, to start getting into deep conversations, into the deep understanding of the domain, you have to get all the bells and whistles around it first. That is not me saying that the bells and whistles are more important than your core domain. That is me saying that they're not. But they sometimes are the only things that stop your deep conversations from happening, so get them out of the way as quick as you can. A couple of negative things that, in retrospect, I would have done differently. Having a Heroku continuously deployed version a month later than we started developing makes sense because that's the point where the rest of the team joined the technical team. However, so there is a good reason why we didn't do it. There isn't any good reason to not do it earlier. We could have done it on week 1, and in retrospect, we should have. And on the future project, I will make sure that we have continuous delivery from day 1. Another thing that I don't know if you spot it or not, we decided to use sample data during the initial build, and that architecture decision is still active, as in it wasn't reseeded or superseded by any other decision. That's because we're still using that. We still weren't given access to the real data within the HMO. And it's a sad state of things, but if I can make one bet on any venture that you start, if that venture has an external dependency, bet on that dependency being late. Another thing that you might have spotted is that, tests, like there's no decisions about tests. We did tests. We write a lot of tests. We spike some part of functionality without the tests, and then we drop that functionality out and we rewrite it with DDD. The reason why you don't see any decisions is that we do consider tests a fundamental part of the architecture. What we don't consider as important is, having discussions around do we do not tests. The analogy that I used with the team is that you don't wake up every morning and make a decision about brushing your teeth or not. It's just a rhythm that you apply to keep yourself healthy. So the impacts is what important. I'm kind of saying it's like here's a lot of good things, but you can argue about them. What hopefully you wouldn't be able to argue is if I provide you examples of why it was great. Having feedback from an expert doctor within the team at the beginning of the second week of development was super important, right? Having end-to-end analysis and the doctor saying, this is good, this is working, this is bad, this is not working, was very important and had a huge impact on us starting to validate the rules early. Having big, fast pivots and rapid decision-making was super important for us. Being able to change decisions all the way through was super important and had a huge impact on the delivery of this project. In December, where we didn't have any decisions made on architecture, there were rapid UI cycles where we would completely change and revamp the way UI works based on the customer feedback, and they will see that feedback incorporated in the UI in a week's time. You can attribute that directly to a lot of the decisions that were made, like Tailwind, like Live View, like keeping the state in memory. The biggest benefit by you looking at this would be that if you look at this, you can for sure say that this is a team that is not afraid to make mistakes. And when you build new products, a lack of fear of making mistakes and ability to recover from them is one of the most important things that you could have. In a nutshell, the interesting aspect of looking at this myself in retrospect is this. I look at those decisions at the very beginning, and I look them in the context of everything else, and I think, well, that is a team that is doing good. But what strikes me is that, If I do take those 4 decisions in isolation, and I say nothing else happens, right? This is the team that is doing really bad. The decisions that were done at the very beginning, if they're the only decisions, you're in a really bad spot for a long time. And the interesting aspect here is that if you look at a point in time, which is the end of the September, and you compare those 2 teams, they're exactly the same. They're in exactly the same state. And that kind of recounted an interesting insight for me that, good or bad architecture isn't a question of what it is at any given point in time. It is a question of where it evolves and how fast it is evolving in response to the real customer and the team feedback. That's all I have. Thank you.